Howdy, my name is Billy Moran. I am the marketing director here at Uplogix, and today we're filming our very first episode of Austin Beer with Network Gear. I'm joined here by James Dollar, our CTO and founder of Uplogix, and we're going to talk a little bit about networking and a little bit about some Austin beer. So I happen to have had a beer or two with James in the past, and I've seen him drink this kind of thing before.
Absolutely.
So today we're starting off with a Cellus White. This is a Belgian style wit beer. So, proceed.
Absolutely.
So James, there's a lot of products out there doing out-of-band management. How is Uplogix different?
I think the key word, Billy, is management. And that a lot of other products are out there doing, giving you an out-of-band connection to the console port of devices. But where management comes into play is actually doing something about the data that we collect. And I like to demonstrate or explain that by looking at what in-band management is. And if you consider tools like SolarWinds that are at your NOC, polling across a WAN, down through a stack of gear, router, switch, firewall, they poll to collect information 99% of the time. Interface statistics, console log messages, memory and CPU utilization of devices. So they have a rich set of data at the NOC. But when a device at the edge has a problem and has broken the management SNMP data, for example, from SolarWinds, those tools are no longer as valuable as they were. Plus, you can't see downstream of the router to see what other devices are having a problem. So what was a rich set of data that was being collected is no longer of value to the team at the NOC trying to do troubleshooting. So management, again, is what Uplogix does better. What a lot of people call out-of-band management is a terminal server at the top of rack at your data center or branch office, cable connected to devices, and it has a LTE modem in it or some network connection, and a NOC technician can log into it and start the troubleshooting process just like they rolled their crash card up to that device and start the troubleshooting process
From scratch.
That's what a lot of people call out-of-band management. But what Uplogix does differently about that is actually do management. And so imagine that you've taken that same rich set of data that tools like SolarWinds collects and you place it at the top of the rack. You cable connect it to each device so that each device has their own path of data collection. And then you poll over that to detect state every 10 seconds by default. We collect information from devices, we put it into a local database, and we look at it over time and decide whether Uplogix should do something about it. Those
All automatically.
are management, that's right. And then if we see something that's actionable, one of the same type of things that a SolarWinds can do at the core, Uplogix can do, but doesn't require any networking to be in place to actually take that action. And so what really inhibits products at the NOC from being able to take action, Uplogix is not inhibited by those actions. And so Uplogix first has a reliable set of data to collect information from, and then it has the reliable way to take that action over the console port. The other things that it does is designed not to work on its own, but to actually backfill those products at the NOC. So by default, after 2.5 minutes of not being able to connect between our local manager and our control center, Uplogix brings up an LTE connection or a dial-up network connection over V92 modems, or even a satellite modem connection to reconnect the NOC and tell the NOC what's going on remotely, backfilling it with information so that the NOC team can take over at any time. That also reconnects centralized authentication, authorization, and accounting, not to mention NetFlow and syslog messages over that out-of-band link. Additionally, if that connection is fast enough, we can even carry critical network traffic over that connection with what we call WAN traffic failure. So Uplogix doesn't always fix every problem. And so those automated steps that we take in the first couple of minutes of the outage could resolve every problem, or may just be the information that we need to hand off to an escalation team to try to figure out what's wrong. But the key to this solution is that we poll very intensively, we find a problem quickly, take those first level actions in the first couple of minutes of the outage. And then if it's not enough, again, to resolve the problem, it's all those things you need before you can escalate anyway. To show you a kind of an example of what that looks like, we'll log into this appliance here. It's actually working over its LTE connection. We've moved to the control center environment, and we can click on this applet to actually launch a terminal into that device. And we'll actually be able to interact with it just like that technician would. Here we're logging into the local manager, and because we have that LTE connection up, and additionally we have an IPsec tunnel up, we can reconnect to our centralized TACAC server, even when the network is down. You can see it's been up for 16 minutes. It's got its VPN active. It's got a 10 dot address from the local carrier. As we navigate to the port, we see that it's a Cisco ISR. We have a couple of monitors running. We're looking at its gigabit Ethernet 000, and we're running a rule set against it called Interface Basic. We're also looking at the chassis monitor, which is basically memory, CPU, and logs. If I do a show alarm, I can see that there aren't any alarms triggering right now, but if I unplug its connection, within a couple of seconds, we'll see that the device triggers an alarm and has detected an up-down state. And then it'll start working through its Interface Basic rule set. Which goes through each one of these rules to determine if there's an action to be taken. And there's our first alarm, is that the gigabit Ethernet port has gone up, down. And also because we disconnected our network connection, NTP servers and clocks are out of sync. So that's just another alarm that's showing up. Well, because that protocol state is down, it's just triggering that alarm. If we plug it back in a few minutes, that'll clear. Notice it's been 9 seconds since the last data was collected. 17 seconds. By the time it collects information again in about 10 more seconds, it'll start to clear that problem. It's following a set of rules to collect information without using the network and take an automated response. In this case, just an alarm message. But we have a lot of very, very complicated actions that we can take.
So rules, rule sets, monitors, these all come with Uplogix.
Absolutely, and they're all tweakable to meet your operational recovery goals. And if you don't want to monitor every 30 seconds, then you can make it slower or over more time. If you want to change the rules so that it is more or less aggressive. Mm-hmm. For example, in a network that has lots of output buffers filling up all the time because it's used heavily, you might be outside of what the Ethernet spec would be for output buffers. But in your network, you're fine with it, so you don't want it alarming you all the time. Or CRC errors. It's going in an old plant environment or an old school in downtown LA, and there's just no way to make that work with the old cabling. But you're all right with it because it generally works. So there's always ways to tweak it to even when other networks would call that an outage. Notice we've had 1 minute 42 since our elapsed timer since the problem started to resolve. At 2 minutes, that'll have a little asterisk next to it showing that it's clearing. You can see that. And then after 6 minutes, it'll go away entirely. But that's also part of a log that's available so that even a short little outage like that will show up in an outage report. And you can go back in time and find small outages like that you may not have ever caught with your centralized tools that default to every 9 minutes for the data collection. And it's all because you're polling at such a high state.
So where are the logs stored?
They're all stored on a local database, and then they're sent up to the control center every 30 seconds. So in the control center will have the rich set of data. The local manager will have the metadata, and the local manager will have all the low-level data. So if you really want to dig down to that information, you can go and find it on the local manager. We just want to see what that looks like. Those monitors, again, are running every couple of seconds. We have a shadow command where we can just watch it run commands and see what it does. It's just the CLI commands that a network admin would take in the troubleshooting of a problem. They just run all the time. So Uplogix's model is data collection, taking the data through rules and determining if there's an action to take, and then rules drive the next action. And just to say that we're all those other things that out-of-band products are, you can also log into the device just like they can. First thing we do, though, is log out of our functional ID. So we're having to force a new user to log in with his own ID. Of course, that can be over TACACS as well, over the out-band network.
Empty.
Let's go have another.